Ferromagnetic substance exhibit the property of saturation. It gets saturated if we increase the external magnetic field, and and another property was that the magnetic field in any ferromagnetic substance will depend upon its previous history. The magnetic field inside a ferromagnetic material will also depend upon its previous history of magnetization. Inside a ferromagnetic material depends upon its previous history.
Good evening, sir.
Good evening, Arvind. Good evening. Yeah. This part we have done in the Tuesday Thursday batch. Just a quick recap because for Tuesday Thursday batch it is a revision, and then we'll do some questions from the this part. Magnetic field inside a ferromagnetic material depends upon its previous history of magnetization. If it is already demagnetized, then there will be different magnetic field. And if it is having some magnetic field is there, then this will have a different magnetic field. This is called hysteresis. This property is called in fact hysteresis. It's not a phenomenon. Hysteresis का मतलब related to the history. So the value of magnetic field inside this property is called hysteresis. So we can analyze this property by using a cycle of magnetization and demagnetization. So उसके लिए we have to choose a soft iron. Soft iron is a ferromagnetic material, and we have to produce an external magnetic field with the help of solenoid. So if there is a solenoid and that solenoid has n number of turns, suppose the iron rod is kept inside the solenoid. So when a current I is passed into a solenoid, that solenoid develops a uniform magnetic field in the whole space. Inside, magnetic field is constant. Magnetic field inside the solenoid will act as the external magnetic field. In this external magnetic field, a iron rod is kept, mu naught Ni. Small n here is number of turns per unit length, and I is the current passed. Number of turns per unit length. So if you remember, हमने मैग्नेटाइजेशन के टाइम पे एक फॉर्मूला डिफाइन किया था, that was magnetic intensity of external field, which will become V naught by mu naught, and that will become N times I. External, the current in this solenoid is increased, and with the increase in current, the magnetic intensity will also increase. H is equal to N times I. By increasing the intensity of external magnetic field, we have to plot the magnetic field versus intensity graph. B versus H. External magnetic field V is Bharat.
Yes, sir.
Right, you remember this part, the hysteresis loop?
Yes, I am able to recall.
Okay. Right, so can you explain what happens when the magnetic intensity is increased? Wait, I will explain. जब हम बाहर से कुछ करंट इसमें पास करते हैं, then there is a magnetic field developed, और उस magnetic field में this iron starts getting magnetized. External field causes the domain alignment, and because of that, magnetic field start increasing. till all the domains become perfectly aligned in the direction of external magnetic field, and now it becomes saturated if the external magnetic intensity is increased, even though the magnetic field will not increase beyond this point. But जब हम magnetic field को कम करेंगे by reducing the current, it will not follow the same path. It will come through a different path, such that every time it has more magnetic field than the previous value. So magnetize करते time 10 ampere पे जितनी भी magnetic field थी, let's say if it is 10 Tesla, now on coming back it will be 12 or 13 Tesla. इसने पहले से थोड़ी सी ज्यादा magnetic field अपने अंदर store कर लिया, so effectively it has slightly more magnetized. Even when the external field is gone, when H is gone, तब भी इसके पास थोड़ी सी magnetic property बची हुई है. This length O to A, this length represent how much magnetic field it will retain inside when the external field is gone, and that is called retentivity of material. That is called magnetic retentivity. रिटेंटिविटी मतलब एक्सटर्नल फील्ड को हटाने पर भी उसने कितनी अपने अंदर मैग्नेटिक फील्ड स्टोर कर ली है. अगर ये मैग्नेटिक फील्ड बहुत ज्यादा होगी, देन इट विल बिकम लाइक अ परमानेंट मैग्नेट. इट विल शो अ परमानेंट मैग्नेटिक प्रॉपर्टी और मैग्नेटिक बिहेवियर. Very nice. Now again, if you want it to become like a normal iron bar, we have to reverse the direction of external magnetic field. We have to apply an opposite direction external field from outside. That will be by reversing the direction of current. So we have produced an opposite direction of intensity, magnetic intensity, and that magnetic intensity at which it will be completely demagnetized again. यानी जो उसने अपने अंदर magnetic field store करी थी, वो फिर से खत्म हो जाएगी. That negative intensity is called coercivity. That is called coercivity of material. अब अगर अपोजिट डायरेक्शन में करंट इंक्रीज करते जाएंगे, देन अगेन मैग्नेटिक फील्ड विल इंक्रीज टिल इट सैचुरेटेड. मैग्नेटिक फील्ड वापस अगेन इट विल शो सम रिटेंटिविटी, अपोजिट डायरेक्शन, और ऐसे पूरी साइकिल चलती जाती है. दिस इज द वन कंप्लीट साइकिल ऑफ मैग्नेटाइजेशन. पहले हमने जीरो से करंट स्टार्ट की, आयरन स्टार्ट्स मैग्नेटाइजिंग to a saturated value. That value is corresponding here. This is the maximum value of magnetization. एक्सटर्नल फील्ड को कम करने पर भी अभी मैग्नेटिक फील्ड पहले जितनी नहीं होगी. इट विल स्टिल हैव सम स्लाइटली ग्रेटर मैग्नेटिक फील्ड. दैट मींस it has restored, it has saved some magnetic field inside. Even when the external is gone, it has some magnetic field left called as retentivity. And to demagnetize it again, we need to apply an opposite direction. We have to apply an opposite direction of intensity called as coercivity. This OA is retentivity, OC is coercivity, and as a result, this size of coercivity and retentivity, this determines the area of this hysteresis loop. और ये coercivity एक तरह से क्या है? This is, इसको हम BH कर्व या hysteresis कर्व बोलते हैं, और इसके अंदर का जो लूप का एरिया है, if there is a greater coercivity, which means more of the energy is wasted just in making the iron bar like a normal iron rod again. जो उसने मैग्नेटिक फील्ड अपने अंदर स्टोर कर लिया है, उस मैग्नेटिक फील्ड को फिर से डिस्ट्रॉय करने के लिए the opposite field that we have to apply is coercivity. So that much amount of energy will be wasted. So area of BH loop represent heat loss per unit volume per unit cycle. Heat loss, energy loss per unit time, per unit cycle, per unit time. अगर हमने किसी रीजन में जहां पे आयरन है वहां पर मैग्नेटिक, यस समवन सेड समथिंग, यस बट एनी डाउट?
No, sir.
अगर हम मैग्नेटिक फील्ड को, बाहर वाली मैग्नेटिक फील्ड को चेंज करते हैं, इनसाइड मैग्नेटिक फील्ड आल्सो चेंजेस एंड कॉजेज अ saturation. Magnetic field कम करने पे it decreases but not the same as it should be because it has retained some of the magnetic field. उसको फिर से वापस normal demagnetize करने के लिए we have to waste some amount of energy. So it is called, yes, it is called magnetic. It is called the heat loss per unit volume. BH कर्व का एरिया रिप्रेजेंट करता है, BH कर्व का एरिया रिप्रेजेंट करता है कितनी हीट लॉस हो रही है, और बिकॉज ऑफ द प्रॉपर्टी ऑफ रिटेंटिविटी एंड कोर्सिविटी, by this property we can choose what material is suitable for which purpose. For example, अगर हमें इलेक्ट्रोमैग्नेट बनाना है, for electromagnet we should choose such a metal which has very low retentivity and low coercivity. Electromagnets are magnetic only when current is passed. Soft iron behave as electromagnet. Soft iron should be used for electromagnet because they get demagnetized almost completely when the external field is removed. But if we have to make a permanent magnet, we should use the material which has greater VH curve area, like a hard iron. Hard iron is nothing but steel or alloys. It is better suited
Sir,
for, yes.
sir, I have a question.
Mhm.
Why can't we use stainless steel instead of normal steel?
Stainless steel also have a high, but stainless steel, there's no use of being stainless here. You have to just use, make a magnet. If magnet even get stained, there is no harm, there is no loss. Stainless steel means you have to put chromium and vanadium extra, which are relatively costly rare earth element. So why to waste
Sir,
them?
sir, I thought that a little bit of the magnetic property gets reduced once iron or steel gets rusted.
No, will not be rusted. It is steel. Steel will not be rusted. The wrought iron and that can be rusted, but the idea is not the rust because inside it is still a ferromagnetic magnetite. The retentivity of that material which is present inside will be very high, or is very high. It doesn't matter whether you get rusted or not. That will not have much impact on the magnetic field. It will have impact on the other properties, but not on the magnetic field. So hard iron or steel already has some other type of elements like carbon is added to iron or chromium is added to iron to make a different version of steel, and it is better suited for permanent magnet. So effectively the property that is desirable for electromagnet, it should have low retentivity and low coercivity. For a permanent magnet, it should have high retentivity so that it retains most of the magnetic field, and it should have high coercivity as well. Why high coercivity? So otherwise, any small magnetic field present nearby will cause demagnetization of this permanent magnet, and its magnetic behavior will be lost. Similarly, if you have to use a transformer, if you have to use something in the AC, alternating current. Alternating current keeps on changing its direction, therefore it will be automatically magnetized and demagnetized. So we should require such a material which has smaller area. Smaller area means there will be smaller loss of energy. So that's why soft iron core is used inside the transformer also. So that is the theoretical part of this magnetism and matter chapter. We did some of the question from previous magnetism and matter questions we haven't done. So some magnetism and matter questions we will do first. From the DPPs only, we will sort out the questions. Sample paper is out, date sheet is also almost going to be out very soon. The ICSC exams are, ISC exams are starting from 15th of November. And I have shared these notes also, the subjective notes for your revision purpose. So, right, you have to go through them also for the थोड़ा बहुत पेज का order orientation इधर उधर हो सकता है, but you will get a quick theoretical revision from these notes as well. So, use them for preparing for the MCQs and okay. I think I haven't sent in the group. I'm sending it again. The magnetism and matter. वैसे तो it is a theoretical part. There's nothing much for bar magnet, earth's magnetism, and yeah. Okay, so I have just shared these three worksheets in the group. We'll be doing some questions from here. Bar magnet and magnetic field lines, and yeah. Did we discuss any question from here? Yes, did we discuss any question from here?
No, sir.
No.
I doubt whether we discussed questions.
Yeah, I don't think so also. Right. So question number 1. Solenoid of length L radius R containing a number of turns and carrying current I can be replaced by a south pole and north pole having equal pole strength separated by distance D like a bar magnet. Find the L is equal to 10, R is equal to 1 centimeter, and is 200. Find the magnetic field at that point on the axis of 10 centimeter due to north pole and south pole. Question number 1 is basically a solenoid and a magnet comparison. A magnet is north pole and south pole separated by some distance, and a solenoid is current carrying loop and number of current carrying loop. So magnetic dipole moment will be N into I into area, that is pi r square. Once we have magnetic dipole moment, we can find the axial position magnetic field by using the formula mu naught pi 4 pi 2 m by r. Right. Anyone got the answer? Anyone got the answer? So we have to just put a magnet instead of the magnetic dipole moment. We have to use mu is equal to n into I into A, and then formula is mu naught by 4 pi m upon 2m upon r. Second is also find the net magnetic field at that point in above case. Fine. Next is second question. Three identical bar magnets are riveted at the center in same place. System is placed in rest in magnetic field. It is found that system of magnet does not show motion. Determine the polarity of other two magnets. So if they do not show the polarity of, they do not show any other, that means the net dipole moment has become zero. The net dipole moment zero कैसे होगा जब if this is north and south, the other has to be south and north like this. So इन दोनों के dipole moment का जितना भी value है, the same is cancelled by the third one. Right, so there are three identical bar magnets are riveted the center in the same plane. Okay. So इनके dipole moment होंगे m और m और तीसरे वाले का dipole moment होना पड़ेगा √2m. Only then they will be cancelled out because the vector summation. What do you conclude about external field? External field is also constant. External field is constant and that is in the direction of the resultant. That will be the direction of external field. And that is why there is no motion or no rotation or no oscillation. Third, a bar magnet of magnetic moment of inertia I through center and perpendicular to plane is cut into two pieces. When it is cut into two pieces, perpendicular to length or parallel to the length. Perpendicular to length करेंगे तो length कम हो जाएगी, half हो जाएगी, and when it is cut along the length, then the pole strength will become half. So in both the cases, the dipole moment is reduced to half of its value. What about time period? Time period of oscillation of a magnet is 2 pi under root I upon m into b. और I का फॉर्मूला होता है ml square by 12, considering it to be very thin like a rod. So when it is increased, when mass is cut into two pieces perpendicularly, mass will be half. Mass will be half and length will also be half. So ये भी half, that means moment of inertia will become 1 by 8 time and the dipole moment will become half. So हम कर क्या रहे हैं, एक मैग्नेट को अगर परपेंडिकुलरली उसके लेंथ के अलोंग लेंथ के परपेंडिकुलर कट कर देंगे, then if it has a mass of m, then the half portion has mass m by 2, length l by 2. So we'll find out its dipole moment and then we substitute in that formula. So I is equal to पहले moment of inertia था ml square by 12, new moment of inertia is m by 2 l by 2 square by 8, that is 1 by 8 into I. I dash is I by 8, m dash is m by 2. So from here we can find out the time period. T dash is 2 pi under root of I dash divided by m dash. Current one of moment of inertia 1 upon 8, dipole moment is half. So time period will become 1 by 2 क्योंकि अंदर ही आ जाएगा 1 by 4. I dash is I by 8 m dash is m by 2, so 1 by 4, 1 by 4 का रूट करोगे तो हाफ आ जाएगा. T dash is equal to T by 2, that is the when length is when magnet is cut along perpendicular to length, and the time period of oscillation will become half. Next is two identical short magnet, each of magnet dipole moment are placed in the separation 10 centimeter between their centers such that their axes are perpendicular. Find the magnetic field at a point midway between the two. दो मैग्नेट्स हैं छोटे छोटे और आपस में परपेंडिकुलर है और उनके एक्सिस भी परपेंडिकुलर है. वी हैव टू फाइंड द मैग्नेटिक फील्ड एट द मिडवे. पहले वाले मैग्नेट के लिए वो बन गए एक्सियल पोजीशन, दूसरे वाले मैग्नेट के लिए बन गए इक्वेटोरियल पोजीशन. सो एक्सियल और इक्वेटोरियल दोनों आपस में परपेंडिकुलर होंगे. देन वी विल फाइंड आउट द रिजल्टेड एज रूट ऑफ b1 स्क्वायर प्लस b2 स्क्वायर. So B1 is mu naught upon 4 pi to m upon r cube, and B2 is mu naught upon 4 pi m by r cube. Right, because B1 is axial position and B2 आगे आप numerical value डाल के and then you will substitute here and calculate. Yes, next of this PDF. So yeah, question number 5 इसको छोड़ देते हैं. A magnetic needle lying parallel to the magnetic field requires W unit of work to turn it through 60 degree. Initially it is parallel to the magnetic field, so initial theta 1 is 0 degree, and now it has to rotate by 60 degree. Work done in rotating a magnetic field or magnetic dipole formula was mb into cos theta 1 minus cos theta 2. Substituted theta 1 0 degree, theta 2 60 degree. यहाँ से हमें mb की वैल्यू मिल जाएगी. The torque needed to require the needle in this position, torque formula is mb times sin theta. mb cos 0 is 1, cos 60 is 1 by 2, so mb by 2 is w. mb will become 2w into sin 60 is root 3 by 2, so answer is root 3w. मैग्नेट को किसी भी मैग्नेटिक फील्ड में टू रोटेट फ्रॉम थीटा 1 to theta 2 we have to do work, and that work done is mb into cos theta 1 minus cos theta. Number 6, a bar magnet of magnetic moment 3 ampere meter square is placed in uniform magnetic induction. This if each pole of magnet experience a force 6 into 10 to the power minus 4 Newton, then the length of the magnet is. So external magnetic field में hypothetically जैसे हम charge particle के लिखते थे F is equal to QE. Similarly for the magnetic charge we can write F is equal to M into B. Each pole experiences 6 into 10 to the power minus 4 Newton. Pole strength into magnetic field is 2 into 10 to the power minus 5. From here we calculate the first the dipole strength, and then the magnetic moment is pole strength into length of the magnet. Right? Magnetic moment is pole strength into length of the magnet. So we can calculate the length. It will come out to be D option. आप बाद में इसको अपने आप कर सकते हैं. These all are the questions related to the board exam also. Yeah, question number 7. Force between two identical bar magnet is added at distance of R is 4.8. Distance को double करते हैं तो dipoles के लिए force is inversely proportional to R to the power 4. Distance is doubled, force will become 1 by 16. So 4.8 by 16 is 0.3.
0.3.
Two identical magnet dipoles of moment each placed at a separation 2 meter with, again similar to the previous question, the first question that we did. Second question, दो magnet है, उनके axis आपस में perpendicular है, and we have to find the magnetic field exactly at the midpoint. So it will be mu naught by 4 pi to m by r cube for one and mu naught by 4 pi m by r cube for the other. Yes, question number 9. A bar magnet is 10 centimeter long. Its pole strength is 120 CGS. 1 CGS unit is 0.1 A ampere into meter. Yep. So a bar magnet is 10 centimeter. Magnitude of magnetic field distance of axis. पहले हम यहाँ से calculate कर लेंगे m into L से magnet dipole moment, and in the axial position distance 20 centimeter from it, the magnetic field formula. So यहाँ पर हम actual वाला formula use करेंगे कि magnet 10 centimeter हम 20 centimeter पर ही calculate कर रहे हैं. So it is not for a short magnet. Mu naught by 4 pi into 2 mr by r square minus a square whole square. Number 10. Let r be the distance of a point on the axis of bar magnet from distance. The magnetic field at such a point is inversely proportional to r cube. For a magnet, magnetic field is inversely proportional to r cube. A magnet of magnetic moment 20 CGS unit is freely suspended in a uniform magnetic field. The amount of work done in deflecting by 30 degree. So when it is freely suspended, again theta 1 is 0 degree and theta 2 is 30 degree. Work done in rotating is mb times cos theta 1 minus cos theta 2. Number 12, the magnetic field at a point x on the axis of a smaller magnet is equal to the field at a point y in the equator of same magnet. The ratio of distance of x and y. So x cube by y cube will be equal to 2. Mu naught by 4 pi to m by x cube is equal to mu naught by 4 pi m by y cube. Question number 13. A bar magnet of magnetic moment 2 MP meter square is free to rotate about a vertical axis passing through its center. Magnet is released to rest from east-west position, then the kinetic energy of magnet. Okay. Question number 13. Kinetic energy क्यों gain हो रही है इसमें from east west to north south position में जाने पे? Because the potential energy is lost. Loss in potential energy will be equal to gain in kinetic energy. It is free to rotate. The magnet is released to rest from east west. So वो पहले है theta 90 degree पे और finally it is theta 0 degree. Theta 1 is 90 degree क्योंकि वो east west में, theta 2 वो फिर से आगे south north south position में. That is the loss. Loss is initial minus final, and that will be equal to loss in potential energy will be equal to gain in. Magnet को पहले east west में पकड़ के रखा था, released, it will rotate and align itself in the direction of north south. दोनों पोजीशन में जो पोटेंशियल एनर्जी में डिक्रीज होगा दैट विल बी सेम एज इंक्रीज इन काइनेटिक एनर्जी ऑफ मैग्नेट. अंडरस्टूड. सो अभी मैं सिर्फ कॉन्सेप्ट समझा रहा हूँ, आप क्वेश्चन को न्यूमेरिकल बाद में कर सकते हैं. दीज आर दी सिमिलर टाइप ऑफ क्वेश्चन जैसे एसएल में भी है. इट्स नॉट वेरी डिफिकल्ट. द इंडिविजुअल सिंगल चॉइस आंसर questions of all the DPPs are quite relevant for even the board exam. If a small magnetic distance x in the end-on position is 9 Gauss, what will be the distance? End-on का मतलब होता है axial और broadside का मतलब होता है equatorial. So we can find because in the end-on position it is proportional to m by r cube. In the broadside it is proportional to m by r cube. 14th answer will come out to be C. 13th answer is given as B. You can verify later on. Number 15. Two equal bar magnets are kept as shown in the figure. तो ये वैसे ही केस हो गया. The last one, two magnets perpendicular. जिनके एक्सिस परपेंडिकुलर है उसके बीच वाले पॉइंट पे निकालते हैं. साउथ टू नॉर्थ एक्सियल पोजीशन में सेम डायरेक्शन में, इक्वेटोरियल पोजीशन में अपोजिट डायरेक्शन में, दोनों का रिजल्टेंट बीच में आएगा. But none of the option is matching them. 15 का कोई भी ऑप्शन मैच नहीं करा. ये एरो नीचे कर लेना. This is the direction of net magnetic field for these two bar magnets. Number 16. Two short magnets of equal dipole moment are fastened perpendicular to their center. The magnitude of magnetic field distance d from the center and the bisector of right angle. क्या सो इसमें क्या करेंगे, देयर आर टू मैग्नेट्स और परपेंडिकुलर है, तो हम दोनों को पहले कंबाइन करके वी विल फाइंड आउट इट्स रिजल्टेंट डाइपोल मोमेंट. राइट. सो फ्रॉम द रिजल्टेंट डाइपोल मोमेंट इन दोनों का रिजल्टेंट आ जाएगा m√2 और उसी की लाइन में r डिस्टेंस पे कैलकुलेट करना है. सो इंस्टेड ऑफ टू डिफरेंट मैग्नेट्स नाउ ओनली वन मैग्नेट ऑफ डाइपोल मोमेंट m√2 इज लेफ्ट और वो उसके लिए है एक्सियल पोजीशन. सो μ0 by 4 pi 2 into m by r cube. μ0 by 4 pi 2√2 m by d cube. Right, it is in the same plane along the angle bisector. दोनों मैग्नेट एक दूसरे के परपेंडिकुलर है, उनके बीच में एंगल बाइसेक्टर पे we will find out the right. Okay, so next one is टू मैग्नेट्स और मैग्नेटिक मोमेंट. ये हमने क्लास में भी किया हुआ है. m और m बीच में 60 डिग्री √a² + b² + 2ab cos theta. For the given figure, the magnet needle has magnetic moment 6.7 × 10⁻². Moment of inertia is this. It performed 10 oscillation in 6.7 seconds. So one oscillation is 0.67 and time period is 2 pi √I upon m into b. Right. So from here, everything time is given, moment of inertia is given, dipole moment is given. We will calculate B. Calculation थोड़ी सी हो सकती है टेढ़ी मेढ़ी, वो आप देख लेना. The magnetic field lines due to the magnet bar magnet are correctly shown. Very nice. 19 तो कुछ ज्यादा इजी हो गया. IIT-JEE 2002. Yes. 19th. सी बाहर नॉर्थ से साउथ, अंदर साउथ से नॉर्थ, बिकॉज इट इज ऑलवेज इन द फॉर्म ऑफ क्लोज लूप, तो ए और बी तो हो नहीं सकते. या ये हमने पहली वाली जो वर्कशीट थी, द फर्स्ट वन व्हिच इज ऑन द बार मैग्नेट, वी हैव डन, एंड द सेकंड वन इज ऑन अर्थ मैग्नेटिज्म. Third one is on the magnetic material and their properties, paramagnetic, diamagnetic. So I'm just quickly taking the questions. Right. Find the magnitude and inclination of Earth's magnetic field at the geomagnetic equator. पहला क्वेश्चन तो छोड़ सकते हो, कोई बात नहीं. इंक्लिनेशन ऑफ अर्थ मैग्नेटिक फील्ड, अब एंगल ऑफ डिप बताना है. इक्वेटर पर वो पैरेलल होता है, सो देयर इज नो एंगल ऑफ डिप. एट अ पॉइंट वेयर लैटिट्यूड वाले को छोड़ देते हैं, उसके लिए कैलकुलेशन tan phi is equal to tan theta by 2 था, something like that. At magnetic north pole it is perpendicular, so that will be 90 degree. पहले में 0, दूसरे में 90 डिग्री, और बीच में tan phi is equal to tan theta by 2 वाले फॉर्मूले से हम कैलकुलेट कर सकते हैं. इट इज अ जनरल पोजीशन ऑफ अ बार मैग्नेट. Short bar magnet of magnetic moment m is 5.25 10 to the power minus 2 joule per Tesla is placed with its axis perpendicular to Earth's magnetic field. At what distance from center of magnet the resultant magnetic field is inclined at 45 degrees? So question number second क्या है? एक छोटा सा मैग्नेट है और एक अर्थ की मैग्नेटिक फील्ड है. At what distance the resultant magnetic field is inclined with 45 degrees? So there are two magnetic field और उनका resultant 45 डिग्री पर है. उसका क्या मतलब है? Both of those magnetic field will be equal. Tan 45 is P upon BH. So when they are equal, then the resultant will be making an angle of 45 degree. Third, consider the dipole model of Earth. ठीक है, ये छोड़ देते हैं. नहीं, कोई थर्ड का जो पहला पॉइंट डिस्कस करते हैं. लेट्स से कंसीडर डाइपोल मॉडल, यानी अर्थ का अगर हम मैग्नेट को, अर्थ की मैग्नेटिक फील्ड को एक मैग्नेटिक डाइपोल की मैग्नेटिक फील्ड अज्यूम कर लें, तो कहां पर मैग्नेटिक फील्ड मिनिमम होगी? एक जनरल पोजीशन में मैग्नेटिक फील्ड का फॉर्मूला डिराइव किया था, म्यू नॉट बाई 4 पाई m बाई r क्यूब रूट ऑफ 3 cos स्क्वायर थीटा प्लस 1. अब ये मिनिमम होगी जब cos थीटा मिनिमम होगा, cos स्क्वायर मिनिमम होगा, cos स्क्वायर की मिनिमम वैल्यू 0 होती है, एंड दैट विल बी व्हेन थीटा इज पाई बाई 2. यानी कि किसी भी मैग्नेट से परपेंडिकुलर यानी इसकी इक्वेटोरियल पोजीशन पे द मैग्नेटिक फील्ड विल बी ऑलवेज मिनिमम. Find the locus of the point with zero dip. Zero dip मतलब जहाँ पे net magnetic field horizontal की डायरेक्शन में हो, and that is the equator only. Magnetic equator पे the Earth's magnetic field will be horizontal parallel to the Earth's surface. Consider the plane formed by the dipole axis and the axis of Earth. One is magnetic meridian, another is geographic meridian. Point P is in magnetic meridian and is in south, and Q be the point of intersection. So point P and Q is the magnetic equator. Magnetic equator में geographic और magnetic equator जो एक दूसरे को कट करेंगे वो करेंगे exactly at the equatorial plane. So since they both are cutting at the intersection of the equatorial plane, declination angle क्या था? The angle between equatorial पे magnetic axis and geographic axis, and that angle was 11.3 degree. So angle of declination is 11.3 and dip will be 0 because it is in the magnetic meridian. Equator के magnetic meridian पे the magnetic field will be horizontal. Horizontal means there is zero dip angle. Dip angle itself is called inclination angle. A compass needle oscillate 20 times per minute at a place where angle of dip is 45 and 30 times per minute where angle of dip is 30 degree. What is the ratio of total magnetic field due to Earth at these two places? Question number 4. So time period of oscillation of compass जब हम उसको horizontal रखते हैं, it is equal to I upon m times BH, and BH is equal to B cos delta. BH is equal to B cos delta. If the angle of dip at two places are 30, 45, then the ratio of BH at two places. BH is B cos delta, B दोनों के लिए same है. Cos का ratio आ जाएगा, so cos 30 by cos 45. At a place where Earth horizontal component magnetic field is 0.8, angle of dip is 60, then the vertical component divided by horizontal component is equal to tan of angle of dip. Delta is 60, so tan 60 is root 3. Okay, number 7. A dip circle is at right angle to the magnetic meridian. अब dip circle को हमने magnetic meridian से 90 डिग्री पे रख दिया. We use the formula magnetic meridian से theta angle पे रखने पे tan delta dash is equal to tan delta by cos theta. Here that theta is 90 degree, cos 90 is 0, so tan delta dash will become infinity. Delta dash will be 90 degree. So which means it will be perpendicular to the plane surface because in that field right? So when theta is 90 degree, cos 90 is 0, something by 0 is infinity, so delta dash will be 90 degree क्योंकि वो vertical केवल एक ही component बचेगा उस direction में, needle will be pointing. इसके लिए आपको पुराने कॉन्सेप्ट याद होने चाहिए, अगर नहीं है तो शायद कुछ समस्या हो रही होगी. A dip needle which is free to move in vertical plane perpendicular to magnetic meridian. ये लास्ट वाला क्वेश्चन ही है. अगर मैग्नेटिक मेरिडियन के परपेंडिकुलर रख देंगे तो हॉरिजॉन्टल कंपोनेंट तो जीरो हो गया, बचेगा केवल वर्टिकल कंपोनेंट, सो इट विल बी ऑलवेज वर्टिकल. Number 9. The true value of dip angle delta is 60. The apparent dip angle delta dash, the apparent dip angle at an angle 30 degree with the magnetic meridian. So theta is 30 degree और हमें delta dash बताना है. Tan delta dash will be tan delta by cos theta. Question number 10. Short bar magnet is placed with its south pole towards geographic north. The neutral points are at distance 20 centimeters from the center of the magnet. जब हम मैग्नेट का साउथ नॉर्थ की तरफ रखते हैं तो एक्सियल पोजीशन पे न्यूट्रल पॉइंट थे. न्यूट्रल पॉइंट और द पोजीशन वेयर अर्थ मैग्नेटिक फील्ड and the external magnet's magnetic field both cancel out each other. एक्सियल पोजीशन पे मैग्नेट के फील्ड जब अर्थ के मैग्नेटिक फील्ड के इक्वल और अपोजिट हो जाती है देन दे कैंसिल आउट, नेट फील्ड बिकम जीरो. दैट इज द कांसेप्ट ऑफ न्यूट्रल पॉइंट. नंबर 11. Two magnets of equal mass are joined at right angle at each other as shown. Magnet 1 has a magnetic moment 3 times that of magnet 2. This arrangement is pivoted so that it is free to rotate in the horizontal plane. In equilibrium, what angle will the magnet 1 subtend with the magnetic meridian? So ये एक ऐसी मैग्नेटिक फील्ड है जिसमें दोनों एम बी साइन थीटा आपस में एक दूसरे के टॉर्क को बैलेंस करें, आपस में परपेंडिकुलर थे। अगर मैग्नेटिक फील्ड का एक के साथ एंगल थीटा है, दूसरे के साथ 90 माइनस थीटा हो जाएगा। m1 into bh sin theta will be m2 into bh sin 90 minus theta. Right, m1 into bh times sin 90 minus theta. bh gone, एक का डायपोल मोमेंट दूसरे 3 टाइम्स है, और फिर एक तरफ sin थीटा एक तरफ cos आ जाएगा। सो tan थीटा इज इक्वल टू 1/3, थीटा इज इक्वल टू tan इनवर्स 1/3। Number 12, a compass needle whose magnetic moment is 60 ampere square pointing towards gravitational north at a certain place where the horizontal component of Earth's magnetic field is 40 microweber per meter square experiences a torque of 1.2 into 10 to the power minus 3. So question number 12, the torque is m into b times sin theta, mbh times sin theta, or bh will be equal to b sin delta. b is given और हमें delta निकालना है with the help of these two formula. बेटा समझ आ रहा है? आई एम rushing through because थोड़ा सा भी हम सिलेबस में पीछे हैं, but if you remember the formula, please, if you don't remember the formula, please check your notes so that at least you can relate what is being told. ये most of the formulas based questions हैं, but you have to learn the formula first. Right, like question number 12, a compass needle है जिसका magnetic moment m is given pointing towards the geographical north. So if it is pointing towards the geographical north, at that position it is not in the direction of magnetic meridian, it is in the direction of geographic meridian, और इस position पे इसको torque feel होता है, that is given as 1.2 10 to the power minus 3. Calculate the declination at this place. So tau is equal to mb sin theta, torque is equal to mb sin theta, and bh is equal to b sin delta. Next, a thin rectangular magnet suspended freely has a period of oscillation t. Now it is broken into two halves, each having the original length. So this again, this was the first question. जब हम half उसको बीच से break कर देंगे, mass भी half, length भी half, overall its moment of inertia become 1/8 times, and the dipole moment become half, so it will be 1/4. Root of 1/4, that become half times. 14th, the length of magnet is large compared to its width and breadth. The time period of oscillation of vibration magnetometer is 2. The magnet is cut along the length into 3 equal pieces. Okay, and 3 parts are then placed on each other. So 14 में क्या हुआ, जब हमने इसको कट किया 3 pieces में, mass become 1/3, length become 1/3. So each portion moment of inertia become 1/27. Then we multiply by 3, that become I/9, and from that I/9 we will find out the time period of this combination as 2 pi under root. (14) में moment of inertia of each part become y/27. बट हम ऐसे तीन पार्ट को एक दूसरे के ऊपर रख रहे हैं, सो total moment of inertia will become 3 times 3 I by 27, or moment of magnetic moment become 1/3. So 3 ऊपर 27 ऊपर आ गया 9, 1 by root 3 times 1 by root 3. Angle of divided is 60 degree. A magnet needle oscillate in a horizontal plane at this place with period t. If this same needle will oscillate in vertical plane coinciding with magnetic meridian. So पहले वो oscillate हो रहा है किसी horizontal plane में. In the horizontal plane, it is oscillating because of the horizontal component. 2 pi under root I upon m into bh. In the magnetic meridian, it is oscillating because of the overall magnetic field, that is B, or B or BH relation. BH is equal to B times cos delta. So we can find out the ratio.
सर कल फिर 6 चैप्टर करेंगे.
हाँ बेटा 6 चैप्टर करेंगे स्टार्ट. यस, कल हम 6 चैप्टर स्टार्ट करेंगे. ये मैं इसीलिए कर रहा हूँ ताकि आपने अगर प्रैक्टिस नहीं की है तो आप इसको एक बार देख लें, साथ साथ दोबारा अपने आप करोगे, देन मे बी you will understand what to do. Question number 17 is direct formula based. The dip circle is set in geographic median apparent angle delta 1. Apparent angle tan delta dash is tan delta by cos theta. It in a bar magnet is oscillating Earth's magnetic field pretty. What happens time period of the mass is quadrupled. Yeah. Next is magnetic material and its property. Okay. So second, first, what does the value of chi b remain same? Does the value for all type of material? No. For paramagnetic, small positive. For ferromagnetic, very large and positive. And for diamagnetic, it is small but negative. An external magnetic field is applied to this material and material is placed in vacuum. Find the resultant. पैरामैग्नेटिक में थोड़ी बढ़ेगी, फेरोमैग्नेटिक में बहुत ज्यादा बढ़ जाएगी, डायमैग्नेटिक में थोड़ी सी कम हो जाएगी. Second question, a ferromagnetic material is formed in the shape of a ring and is placed inside a toroid. If a current I is passed through the toroid such that net magnetic field produces B, find the expression for intensity of magnetization of this. Intensity of magnetization होता था magnetic dipole moment. So उसको हम calculate करेंगे in terms of M. The net field produced B is equal to mu naught times H plus M. So it will become B by mu naught minus H. And that H is produced by the current passed into the toroid. Number third, find the percentage increase the magnetic field when in the space when a current ring to a rod is filled with aluminum susceptibility. So अगर हमने एल्यूमिनियम नहीं रखा पहले वैक्यूम है then B naught is mu naught times H by putting some susceptible material mu naught into mu r times H where mu r is equal to 1 plus chi. Right. So we can same formula. Fourth, a bar magnet has pole strength 4.5, magnetic length 12, cross section area 0.9. Find the intensity of magnetization. Intensity of magnetization क्या था? Net dipole moment divided by volume. Net dipole moment divided by volume. So pole strength ऊपर जो magnetic length, so magnetic moment is pole strength into length and divided by area into length is volume. So intensity of magnetization will also become pole strength to area ratio. Okay. For mercury at 40 Kelvin, the magnetic susceptibility chi has a value. Question number 5. What should be the answer? Mercury is diamagnetic substance, so it should be negative and positive. It should be negative and small. Okay. When a small magnet is placed above the disk of a material which is kept at low temperature, the magnet is levitation over the disk. The disk must be. Question number 6 answer क्या होगा?
So diamagnetic.
हाँ, superconductor. ये तो पढ़ा था Meissner
Oh,
effect.
sorry. I thought in terms of if the field lines go away from the conductor, then magnet will project.
It will be slightly repelled, but it is a superconductor. It will be completely levitated. Mercury is diamagnetic. Diamagnetic is negative and less than 0. Yeah. Curie temperature is the temperature of transition from ferromagnetism to paramagnetism. The material suitable for making electromagnet is low retentivity, low coercivity. The metal of permanent magnet should be high retentivity, high coercivity. The needle N1, N2, and N3 made of ferromagnetic, paramagnetic, diamagnetic substance. A material when brought close to them will, a magnet when brought close to them. Ferromagnetic strongly attract, paramagnetic weakly attract, diamagnetic is weakly repel. So answer will be B. For the figure, B is the flux density and B naught is. So ये जो B versus H था, अभी उसमें हमने B naught में बस mu naught से multiply और कर दिया है. So graph is same. It is the similar hysteresis graph only. The x-axis is multiplied by a small constant which is mu naught. So for the sample to be suitable for making a permanent magnet, OQ should be large. That is OQ representing the retentivity. And OR should also be large so that it should not get demagnetized by presence of any near magnet. Relative permittivity, permittivity of material are epsilon or mu r respectively. Which of the following are allowed for diamagnetic? For diamagnetic, okay, epsilon r is that electrical property, so that is always greater than 1. For any material, dielectric constant is greater than 1, and the relative permittivity for permeability is less than 1. So which option is possible? Only B. And the AEEE means J main. So these are the questions. Even they are useful for the board exam. Select wrong statement. Diamagnetic substance, direction of magnetizing field intensity is opposite to magnetic intensity. That's correct. Or that's wrong. In paramagnetic substance is along magnetic field. In ferromagnetic substance is along the magnetic field intensity. In diamagnetic substance is along the magnetic field intensity. Which is wrong? D. In diamagnetic substance, the intensity is opposite. Paramagnetic substance, mu r is greater than 1, chi is positive, 14 answer is A. Yeah. Magnetizing field, so that is H produces magnetic flux phi and iron bar the susceptibility. So phi is equal to B into A. From here we get B and from B we get mu. Mu is equal to B by H, which is equal to mu naught into 1 plus chi. From here we get susceptibility. So पूरी calculation है, but okay, 16. Iron की density given है, mass given है, we'll find volume and then the total magnetic moment upon volume is intensity of magnetization. Coercivity of small bar magnet is 400 to the power 3. It is inserted inside a solenoid and length 1 to demagnetize the amount of current that is passed. Coercivity H is equal to Ni. N is the number of turns. We'll substitute. 18. The correct variation of intensity of magnetization with respect to magnetizing field for a diamagnetic substance. For diamagnetic substance, it is negative and small, so it should be OC. The slope should be small. This is that formula. M is equal to chi into H, small and negative slope. A uniform magnetic field parallel to the plane of paper existing in the space initially directed from left to right when a bar of soft iron is placed in it, the direction of force passing through. So it will be attracted by the iron, answer is B. The variation of magnetic susceptibility for ferromagnetic substance, it decreases initially and then after that it will become rectangular hyperbola. 22. Nickel shows ferromagnetic property room temperature. The temperature increases more, then it will become 22. It will become paramagnetic because nickel, iron, cobalt are ferromagnetic. Above the Curie temperature, its behavior will become paramagnetic. And the 21 is paramagnetic net magnetization. Net magnetization is chi into H. H is equal to B naught by mu naught. So chi is inversely proportional to T and H is proportional to B naught. So magnetization is proportional to B naught by T. B naught is changing 0.6 Tesla to 0.2 Tesla and the temperature is changing from 4 to 16. So we'll find out the new dipole moment or new magnetization vector. Capital M is magnetization. So all the three DPPs of this last chapter objective question I have quickly gone through, but this is not sufficient. You have to do it on your own again. Not the integer type, but at least all the objective you should go through for all the MCQ exam preparation. Next class for the weekend batch tomorrow, we will start the electromagnetic induction. Okay. Thank you.
Thank you, sir.
Thank you, sir.